Hello everyone, and this is Dr. Ravi Changlef from Team Edureka taking a particular important session on data science with R. Okay, today we are going to discuss machine learning, applications of machine learning, languages for machine learning, especially R for machine learning, then types of machine learning algorithms and implementing machine learning algorithms with R. Hope everybody is aware of two things which I'm going to discuss today. One is machine learning, second is R programming. If not, then I'll make them clear, right? What exactly is the basic concepts regarding the same. Number one, if I talk about the very first agenda, that is understanding the machine learning, right? So what exactly is machine learning? It's nothing else but I make my system or a computer or my particular, any kind of a mobile functionality or a website which has the programming part to understand what exactly would be the future of my data or what solution I can prescribe by getting the insights from the data sets. It could be for customers, it could be for employees, it could be for suppliers, bankers, anybody. So whatsoever, whosoever is there in your business circle, mainly the stakeholder of the business, for them we apply data analytics. And machine learning is a process to perform data analytics by automating the task of taking decisions to predict a given variable and also to prescribe a given solution. Are we clear on this? So we have four things to do: describe my data, then diagnose the data sets, and then what we do is we go for predictions and prescriptions. So there are four parameters of data analytics which can be useful for gaining insights from the data. And what we do is we have a machine learning programming for that. So we use a language that is R. Today I'm going to demonstrate in R. We can even work with Python for the same. And so we discuss all these agendas today. So understanding the machine learning, right? So what is machine learning is basically I told you that we have three different types of machine learnings. So if a guy is looking at this fish, right, we ask or he asks what exactly is this? So he uses his eye, right? He uses his eyes to scan the shape, size, and color of the particular animal, and here he finds a fish over there. So he have a memory over there. Similarly, we can make a machine to understand object by having object detection patterns by using camera, and this camera will be using the kind of clicks to have some pictures, and these pictures can be transformed into different types of dimensions, that is arrays can be created in terms of binary numbers, and we now work on these arrays and objects to scan the image and predict whether this particular object is a fish or a cow whatsoever comes in the frame. So face application, basically they have used this. Next, so there's another fish, right? We can understand that from the past from the past data sets, I can find that I have to, when I say I want to even discuss whether a particular object is or a particular, the client is good for me or not. So I have to understand the past records. Without past records, I cannot understand the behavior of the client even. So therefore, we need to have machine learning. So how do you all know all these are fishes? Because from the childhood, very early childhood, we have understood this. Now the computer can identify this. They got a particular picture or an image, processing can be done, and the computer identifies whether the particular fish, I mean the picture is of a fish or whatsoever, and which species of the fish it is there. So machine is understanding from the images what object is in front of it. And so the new data, whatever, for example, now this was the past record, and now immediately I get a particular new data of a new fish, right? The computer will now understand that it's a kind of a fish only. If it has fins, it has eye in front, it has a mouth over there. I mean, whatever the kind of features, the computer can scan over there, we can mention the features even, and definitely we get to know the result is going to be a fish only. So application machine learning are everywhere. I told you that be it travel, be it healthcare, be it a sales department, be it credit and insurance, be it automation industry, be it a kind of a social media or say marketing, everywhere we require machine learning today. That's why I said that whatever domain you're working, you can apply machine learning inside. I think this is also clear. So let me just have some use cases. So basically for marketing, what we can do is in marketing, we can see that whether a customer will remain with me or not. Okay. So on what features the particular prediction would be there? The feature would be number one on the basis of, whether the customer, what kind of transactions I have with the customer, what kind of services I give, and what kind of, perception he's carrying, and whether he's satisfied with my services or not. So in all of this, satisfaction plays vital role with the customer, right? Affordability to pay and willingness to pay, there are two things, right, to buy a product. So affordability comes from the income. If the customer is not having income source, he is not going to buy anything. But if he is having income but not willingness, Okay, then I can probably make I can ask the I can improvise my services, and I can retain my customers. Similarly, if I can apply logic over there to predict who's going to be with me or who's not going to be with me, so I can use a marketing skill set over there to retain the customers. So what we do is we work on customer lifetime value creations models out there, which works on customers churn predictions. Churn means what? Whether they are going to switch or not. Okay, then we can have social media analytics. The positivity and negativity of the tweets or comments or post on the Facebook, they are positive or not. So that classification we can do. Okay, what is the impact of my speech or the government speech in the public on the social media? That we impact we can study. Going for text mining approaches, we can have text mining approaches over there to work on social media. So we have natural language processing for that. In automation, we work on IoT principles, Internet of Things, pilotless aircrafts, drones, etc., which are riskier nowadays, you can see. So we can even work on that automation. That automation is along with IoT. So we have, Python along with a Raspberry Pi chip. They can get, integrated. And this integration helps me to automate my device, electronic device. Apart from that, I can get into claims prediction, which I told you that who's going to claim that beforehand we can get the information today. And as I told you about Lakshmi Priya, that fraud and risk detections also can be done very well nowadays with machine learning. So we can see whether the client is going to pay, how many number of bounces were there, what was the past performance of the client. So if I have identified there are two guys who are having same behavior, one was the old client, this is the new client, I can identify the same features of the clients are there. The second guy is also going to default on the basis of those features. So apart from that, we can also get into sales. Automated sales can be performed. So recommender systems works very well here. If you are sitting in some places like Shimla or say Kashmir, and in that case what you do is Amazon comes to know about this and on the base of your location. And then if it's a winter season, definitely you are going to get a strong recommendation for woolen wear. So that's how exactly my automated sales would take place. Understanding my feature, my locations, my interest, taste, preferences, etc. Similarly, they can use the features of the clients to avail discounts, and even they can just take out the demand forecasting. Apart from that, healthcare can use it for disease predictions, what kind of medical drugs can be recommended. That also recommender system works over there. Apart from that, we have dynamic pricing model for the travel agencies, and they can change their prices as per the thrust or as per the kind of population or say the density of the crowd over there on the airports. There are so many things we can do. Today I'm going to demonstrate with fraud detection even. So credit card fraud detection, we can do it on our programming, right? So now let's come to one of the aspect of your, what we say is, let me show you one Excel file, then we can work on it. All right, can you see my Excel file? If yes, then I'm going to show it here. So I told you that machine learning is nothing else but ability of my machine to take decisions without being explicitly programmed. Okay, so machine learning is divided into three parts: supervised, unsupervised, and then reinforcement. So there are three different types of machine learning algorithms we have. Supervised. So in supervised, I have input along with output. If I have input data and output data, it's supervised algorithm. If I have only input data, it's unsupervised. In reinforcement, what I have is I have a given environment like driverless car. If I want to have, I need to have environment. What this environment carries? This environment is comprising of, what we say is, let me write it here only. So environment carries now certain states, means distances we can measure. It has some the detailings on the entire environment, that is pedestrians even. They can be a part of your environment. There would be a passenger who's sitting inside. Okay, we need to also understand where we want to drop this particular guy over there. And also there could be some signals on the road. So these are all the kind of aspects of environment which are we call states. On the base of states, I have to take some actions, right? Because if there is a kind of a bad road, I have to take either left or right. So taking left turn or say right turn or a U-turn. All these things are action part, right? So I got the states, I got some environmental aspects, I have got actions, then I have to just deliver a response over there. So there has to be a response, right? Then apart from that, what I have to understand is if a car is moving on by its own, it also requires, a kind of processing of some policies or say rules, right? So there has to be some rules and policies. On the basis of policies, the actions would be taken. For example, if we design an algorithm in such a way that whether there is a kind of a bad road, okay, just scan it, and on that basis you take a left or right. So this policies I develop with using the algorithm. So here I use the particular algorithmic particular aspect. So algorithms are developed to set rules and pro policies. On those rules and policies, my entire actions are being taken up. Why I am able to work out on this? Because the car is connected to my Python programming, right? So I have IoT, that is a Raspberry Pi chip or something can be there. A device can be there inside my car. This car also have a GPS facility, navigation facility, and it has internet facility even. So therefore I can track the car anytime. And there are certain policies and possible rules which I can create and I can work on it. So what I say is basically I'm going to have this kind of aspects. So are you getting, guys, what exactly is the algorithm part or the machine learning is divided into three parts? Supervised basically means what? When my data is divided into having input and output both. Can anybody highlight what is this input and output? If I have to predict something like rainfall, I have to predict what? Rainfall in inches. Which algorithm I can use? I can use supervised because I have input and output both. So can you define now what is the output, what is input for the rainfall prediction? And by the way, what I can do with the algorithms, I can have predictions. So supervised, whenever I use, I mainly go for predictions. I go for prescriptions. Okay. So I can use prescriptions in both the cases, right? Here it's more about predictions. It's all about prescriptions, right? So prediction is getting into future. Prescription is to give the results today and to have the solutions today. So we have reinforcement learning, unsupervised algorithms, all for prescriptions only. If I want to predict rainfall in inches, this basically whatever the thing I need to predict is going to be the output for me. So output is nothing else but rainfall in inches, that is past record. So this should be a past record for me. Okay. Understanding the past, I can take the decisions for future. So past record has to be there. So I say that rainfall in inches is basically my data, that is output. What is input? This rainfall is dependent. For example, we assume that this rainfall is a function of temperature, then atmospheric pressure, okay, also say humidity. Just only these aspects. Season is also there, but let's see. It's a function of temperature, pressure, and humidity. Even let me write season also, because in most of the monsoon season only we have rainfall. Now these are the inputs, right? So input can be many. Output, I'm going to predict something, so it's an output here. So if I have these kind of inputs here only, and I don't have the output to be predicted, I call it unsupervised algorithms can be used here for these databases. What we do with that is prescription, right? So I prescribe there could be a rainfall, but I'm not predicting it, right? Now I'll come to that. So we can get into segmentation. In unsupervised, what we can do is we can have, let me just decrease the size. So what we can have is we can have segmentation techniques, clustering basically. So segmentation of customers, cluster, or say segmentation of employees, salaries, or something. Even we can get into the customer segmentation. We can have market basket analysis. We can have a reinforcement learning kind of mechanism for the unsupervised part. We can also get into the anomaly detection. That is, I know something suspicious is there, so we can detect something suspicious in this input data. Detections. Okay. Likewise, we say that this is unsupervised. So in unsupervised, we only have the input. No output is required. Output is what? Something to be predicted. Here I don't want to predict, I just want to classify or cluster it, or to identify a particular, whether there is a kind of a fraud kind of thing inside or not, without predicting the fraud. What is the difference between supervised and unsupervised? In supervised, I have the only input along with the output, and in unsupervised, I have only the input data set. Output is missing. So this output data is nothing else. I also call it a label data. So what exactly is named as? It is named as, it's named as labeled. This output data is also known as response variable. This output is also known as target variable. This also is known as dependent variable. Okay, this is also known as dependent variable. Variable means what? That value which varies. Input is also a variable, right? So we have independent variables over there and dependent variables in supervised. Okay, in unsupervised I have only the input data. Now if I talk about the techniques which are employed here, you can see that if I have supervised learning, in supervised learning what I do, I told you that we predict mainly. So we need to understand data is of two types. Continuous data. Okay, we have two types of data sets. Continuous. Now let me just increase its size. Oh my goodness, what is this? Freezed. Okay, it's freezed, right? Now it will be okay. So now I say that supervised algorithms may have two types of data sets, continuous and say categorical. Now what is the example of continuous? If I say rainfall in inches, I have two types of things, right? One is rainfall in inches. Okay, it's continuous. And whether it will rain or not. Rainfall not in inches, but whether it will rain or not rain. So I have the values like 0 and 1 here. So this is a categorical data. Now we clear, guys. So I have two different types of algorithms. Number one, on the base of categorical data, I have different algorithms, and on the base of continuous, I have different algorithms. When my data is continuous, I apply what? Regression. So there is a technique known as regression. If you are aware, it's okay. And when I have categorical, I can apply classification algorithms. So I have classification. On the base of what? If I predict rainfall in inches, I use regression models, which are having the linear equations. When I'm working on categorical data, that is the data is having some 0, 1, 2, 3 like kind of a discrete values, we work on categorical data sets. That is classification algorithms. Algorithm means set of rules to be understood by my computer. Now if I say the range is to be understood, so it has the range 0 to infinity, right? Here the range is 0 to infinity, that to whole number, right? I cannot have decimals. Here you can understand the range is basically fixed as minus infinity, okay, to plus infinity. Okay, so minus infinity to plus infinity is my range in continuous data sets. And here categorical has 0, 1, 2, 3 like kind of a structure. And therefore classification algorithms are being used over there. So we have in regression models, we have got linear regression, we have got polynomial regression. Okay. Apart from that, we can also have decision trees even. So decision trees are common to both continuous and categorical. Okay. Similarly, I can have, in categorical, we can have support vector machines. No need to worry if you are not aware of it. I'm going to elaborate. Naive Bayes is another algorithm. Logistic regression is the most important one. Okay, it's a regression based algorithm, but not a part of continuous. It's a categorical. So logistic regression I can work upon. K nearest neighbors I can use. Okay, decision trees I can use it here again. Alright, so these are some of the algorithms which are most common. Like that, if you go on identifying, there are a hell lot of algorithms. I mean, more than hundreds of algorithms which are there. But mainly these algorithms you should be aware of as a data scientist. So on the basis of my data, I predict something that is using continuous. If my data is continuous, having the range of my minimum minus infinity to plus infinity, any value in decimals, minus whatever, I get to work on continuous. And if my data is categorical, divided into classes, like the output is basically divided into classes. So here my data input could be anything, but I'm talking about output variable. So mainly I'm talking about output. If this output variable, okay, this output variable, if it is going to be continuous or whatsoever, then I apply these kind of algorithms. Okay. When I come to the another thing, when I have input could be anything. Input could be continuous or say or categorical anything, but mainly output decides which algorithm I should apply. Apart from that, I have inputs here. This inputs if they are continuous, okay, if they are continuous or categorical, we apply again certain different techniques. If my inputs are basically continuous, I can apply a technique which is known as factor analysis or say PCA, principal component analysis. If my data is going to be classification or say on the base of categorical, I can apply cluster analysis or say K means clustering I can do. Even I can get into hierarchical clustering. There is another technique known as fuzzy clustering. Apart from that, I can also get into market basket analysis, which is dependent on association rules. This is basically nothing else but, deciding, okay, deciding which product to be sold with another one. For example, you might have gone to Amazon. In Amazon, they say that most of the customers who have bought this also bought that. So it's a association rule mining kind of thing. Recommendation on the basis of market basket analysis. They know that if I'm buying a mobile phone, they will definitely recommend a, the kind of a cover of mobile, right? It's a best product which is bought along with a mobile. So it's an association, right, with the product. So likewise, we can have recommendations for medicines which are not adverse to each other. So what kind of basket I can create for my clients, and what kind of any combo offers I can give. All these kind of techniques are MBA techniques. All right, and I told you that driverless car kind of algorithms are already this, and here we have so many things. We have set of given set of environment which has some states. We have to take some actions over there. Response is to be there. Then there is something policy. Then we talk about penalty, right? So they have penalty and reward system to understand the accuracy. Penalty is that, for example, if I set a time of my car to be reach a particular destination was set 10 minutes. So if it reaches in 12 minutes, I get 2 minutes of penalty, right? And reward is basically I get a 5 minutes of reward if if I set my car to reach there by 10 minutes, it reaches in 5 minutes. Okay, so it's minus 2 minutes, it's plus 5 minutes. Okay, so languages for machine learning is basically R, Python, then Java and MATLAB. You can just see to it what exactly is most preferable. So I just prefer Python, then second I prefer R, then I prefer MATLAB, then I prefer Java, because Python and R, they are more open source, and yeah, it's not only open source, but they are more comfortable, and we are more comfortable. We have casual programming inside these two languages. So it's highly dynamic. It is easily interacting with any kind of a system. I can have web designing even. I can have web development, app development. I can have website API creations over there with Python. There are so many usefulness of using any of the particular platforms like R and Python. So why R we should use? Because it's open source, it's object oriented, object and classes. We can work on the databases over there. It is a functional programming. Basically, I have some built-in functions which we can use readily. So no need to program them. So if I use head of a data, that means what I'm going to get the total first 5 observations. If I use tail, I get last 5 observations. Number of rows I can identify of this data, number of columns I can identify. And Turing complete, I mean natural language processing and all these things can be easily working on that. So let's see in the steps in machine learning. So step number 1 of machine learning is target a problem. For example, if I want to predict whether a particular customer will default or not, so just put the data which you require over there. Second, identify from where you can get the information of the client. Data wrangling can be there now. Data manipulation could be done. Train the algorithm means what? Use a particular algorithm which is required by you. So here, if my data is categorical, which algorithms I can use for training my data? So what is training? See, training is nothing else but a kind of a concept. For example, if I want to predict something, whether it will rain tomorrow or not, so I have to wait till tomorrow to see actually whether I have predicted correctly or not. So what I do, I just go back, I take the 100% data, I divide this data into two parts, 50% and 50%. 50% of the data is training, 50% is testing. Training data from the past is that data on which I'll be building a model, and equation would be identified, some parameters will be identified. On that basis, I predict the future. And when I go to the future, that is from the past only, I can test it, right? That whether when I said that it will not rain, has it rained or not? From past only I can predict that. So that observation which I use for my testing the algorithm is known as testing data sets. So I have training data and testing data. Training is again from past, testing is also from past. Okay, from present I can take, right? But even I can take the data from past so that I can check the accuracy of my model. If my accuracy of the model is perfect, I can use in future this model as a replica and I can work on that. Training and testing is just to make you clear whether past can be used to predict the future. So I have divided my data into training and testing. So I have the algorithm over there, the logic I am writing to just predict what will happen in future. Next, what I do is I get the test the algorithm. So test the algorithm on the test data. Okay, then what we do is we evaluate the results. Okay, whether the accuracy is there or not. Types of machine learning, I told you that we have different types of algorithms here. Okay, we can have machine learning as supervised, unsupervised reinforcement, supervised regression, decision trees, random forest also is a multiple decision tree becomes random forest. Also I can apply there. So in supervised, if my data is categorical, I can apply classification algorithms like KNN trees, logistic regression, neighbors, support vector machines. Here if I talk about the machine learning unsupervised, singular vector decomposition, principal component analysis, k-means clustering we can apply. Association analysis by association rules or market basket analysis we can work. Hidden Markov model is another thing which are there. So I think we have discussed this. Supervised learning means what? Supervised learning algorithms means learning from a known data set, that is training data set, to make predictions. So I need training to perform well in the test. Classification, dividing the data into two parts, right? And seeing the picture and predicting whether it's a male or female. So that we can check with this classification algorithms. We have a decision tree mechanism. This decision tree mechanism, if I use for classification of data sets, what it does is it has a root node, right? Which works on two statements, whether it is true or a false. So if it is a true, again, whether the another condition is met or not. So it's basically multiple condition model. So we check out the conditions are met or not properly. So we have a path to from root to the the leaf of a particular tree. That's why they are known as what we call it, say, decision tree mechanism. So we can now have some algorithm checks using classification analysis. I'll be working on default predictions using classification algorithm. Then we come to regression. Okay. Then we come to unsupervised. So I can divide my data into clustering, then reinforcement. So driverless car, drones, etc. And then all these things, basically they are, part of it. Okay. So I'll be now discussing all these data sets, and with that we work on different types of algorithms. Then we wind up the session. Are we clear with the things, guys? What I'm going to do? So I'll be using now R to work on different types of data sets to have different types of algorithms. So let's see the guys how exactly we can use different types of algorithms. And to save time, what I have done is I'm using my available, what we say works, which are there on different algorithms. So to give you a basic description on R, first of all, so R looks like this. You have one pane here. Let me just highlight it. When you are working for the very first time on R, where is that? You can download R from here. So download R. So just download the version of R which is suitable to your configuration, 34 or 32 or 64 bit. And after that, you run it, the system file, and then download RStudio. You have to download both. RStudio is kind of an integrated development environment, right? So we can work on that. So then download RStudio. First of all, download R, then download RStudio. Once you got the RStudio, your RStudio looks like this one. So just click that. After completion of the download, you'll be getting the software to be accessed by you, and you can just have this programming language now here. Let me just take new, right? So let me just open up a new file as a script. Okay, so what you can see is now I can start working on my programmings. So what is my program here? I can work on some of the data sets, right? So for example, if I say hello, okay, and if I run it, so here I'll be using the scripts. Okay, here I'll be writing my commands. Here I can see the execution of my commands. Let me just scroll it down, right? All right, let me just clear it. Let me just clear it. Let me now work on it. So I got 4 panes here, 4 windows or panes, whatever you call it. Now, this particular portion is basically what? This portion is going to be, this pane is going to be your script pane where you just have the inputs. You can see the commands are being worked out in the console, the second part. Here the data will be stored here. Here you can work on data visualizations. So data script, output of that script, then data, and then what we have is we are going to have data visualization or the plots which will be worked out here. Now what I say is if I write hello here, you can see that I get some errors, right? So error object hello is not found. The reason being because I'm working on a string or a character. So what I do is I just use a double quote over there or a single quote over there, and once I print that, now I get hello as hello. Okay, if I say a is equal to say 10, okay, I run that, and I say b is equal to 20, I run that. So you can see I have got a and b values here automatically, and c is equal to say a plus b, and I just write here c, I get 30, right? So these operations I can do it. So what things you need to learn, right? Not right now in this session, because today I'm going to discuss machine learning. Those who are new to R, what should they understand is, first of all, number one, they should understand how to, what are the data structures in R? Data structures in R. Second, you should learn how to work on, operators like plus, minus, and all arithmetic operators, binary operators, logical operators. There are so many operators out there. Just see to it what are the types of operators I work upon on R programming before reaching to machine learning, because our agenda is machine learning, so I am directly working on that. But you should understand what is the data structure, what are the operators in the R language, how to work on loops, how to work on conditional statements. Apart from that, what you need to work is how to work on some of the aspects into loop control statements. So we got conditional statement, loops, and functions also you need to work upon. At least this is clear, right? The next thing which you need to process and program basically would be to perform statistics on given set of data sets, right? Then have some data visualizations. Okay, after data visualizations, what you do is you should work on data manipulation. Then probably you can work directly on machine learning. So these things are prerequisite to understand the things from here. You would have understand to have a bit sense on data structures, how the data structures are being created, operators, loops, controls, control statement, conditional statements, functions, statistics on our data visualization, data manipulation, etc. My exercise is going to be now basically for machine learning, right? That is a logistic regression model which I'll be using. And you can directly work on some of data sets here. So for example, if I write empty cars, it's a data which is available directly on your R library. You can see that this is my data, guys. Okay, so for example, if I say empty cars I'm working, I say data is equal to empty cars. If I want to extract some values from here, so I say data dollar, I use dollar sign to extract any of the particular variables, for example mpg. So I get one variable here, data dollar mpg. Okay, now if I want to extract another variable, data say dollar cyl cylinder. So it's a cars data basically. If I want to just, you want to just work on the data, it is basically different types of data set I have got for my cars. I got the model make, I got the mpg, mileage per gallon, cylinder type, displacement, horsepower, all right, weight, then vehicle type, all right, and the carburetor, etc., gearboxes and all. So this is the data which you can directly work upon. Now what we do is we can now program, we need to work on stats. So we have to, you can import some packages here. For example, there's one package which is known as E140, E1071. So I come here. So here we can, employ some packages E1071, okay, and install that. So what you require is you will be requiring some packages which are already programmed packages. So it will take some time and it will be finally downloaded here. And you can use this library now to work on it. What you do now, you just write library, okay, and library of what? E1071. Okay, now this particular package or the library is being processed here, and I can do anything from this. So if I want to write a skewness of my data, right, SKEW, skewness of what? Of my data, dollar mpg, that is mileage per gallon, the skewness. You can see that I get the results here 0.610, right? So that means my library which I have installed here, that is E1071, which is for statistical operations in terms of skewness, kurtosis, etc., it is working. All right, then what we do is let's come back to the logistic regression use cases, and I'll show you what we can do with this. Let me just delete all the operations here. Let me delete this. Let me just come to plots. Let me just delete all these observations, and let me come to here. Okay, so when I'm working on any of the particular machine learning project, here I have to work on credit risk data set. Okay, credit risk data set should be available with me. So what I do is I just come up here and I come to my folder that is having some data sets. So I have data sets. I have got this particular credit data. So this is present in my folder. Okay, so I copy this path. So I just copy this path. That mechanism I can use to just get this file over there. Or second shortcut is go to your session. In session, choose your working directory. Okay, and choose this directory. I repeat, go to session, set working directory, choose directory, and in that directory you can mention where this particular what we say data is present. Okay, so let me come up here. So it's my data set, right? So I just choose this data set folder which will be accessed. So once I created this working directory, you can see that it is highlighted here that my working directory is this. Now this file working directory has one file that is credit data. So I simply run this. So read.csv is a function to read my data from my existing folder. Okay, so I just say run it, and let me write a shortcut for this. Let me just write data. Okay, now when I highlight this data, this is my data set of the CSV file. Okay, which is what client ID I have got income, age group, the loan values, how much loan person has taken, loan to income ratio, and whether the person has defaulted or not. So I have got input and output both. Default is that particular variable which I want to predict. So it's a output variable. That means I can apply supervised algorithm. In supervised, you can see that my data is 0101 like that. Okay, so I get 0101 means what? I can apply classification algorithm. In classification algorithm, I can choose any of the algorithms like support vector machine, neo bias, etc. Basically, I'm going to use what? I'm going to use logistic regression. So what I do is I just read the data from my file folder. I got this. To work on the data sets first 5 observations, I write here head of data. So I get first observations here, 6 observations. Okay, if I write tail of my data, I get last few observations of my data set. So you can see that I got the last few observations just to check the data, what data I have. What I do now, let me just have the column names, right? So column names of data I'm going to prepare. So column names are ID, income, age, loan, LTI, and default. Let me just collect that, right? And I attach this data so that I need not write again and again the file. So I just attach this. So I can attach this data. Then I divided, what I told you is first of all, you have to work on training of the data set. So what I say, I divide my data into two parts. ID value less than 1600. This entire data should be training data. So training data is what? All those customers having the ID value less than 1 to 1600. That means 1 to what we say. Let me just show you what is the training data here. Train underscore data set. If I write here, okay, the spelling is wrong, right? It's Tareen. So train underscore data set. I got this many observations, right? So I got these many observations here. All right, till 1600. Now I use a not symbol here. That is not training dataset. Training dataset, whatever now is more than 1600 will be testing dataset. So not a training dataset, then it is testing dataset. So I can use this shortcut. So data, if it is not training dataset, I can use a testing dataset. And what I do, guys, I simply come here, I apply the logistic regression. My actual, what we say is objective is to predict a particular person whether he is going to default or not. So that prediction I can do very easily now. By what? By having logistic regression, one of the algorithm which is the supervised algorithm that is in the classification family. So general linear model I work upon. I choose the model and the formula is right. I write here that default rate is dependent on income plus age plus loan. Data is going to be now, okay, data is now data only. The file name is data only. Subset is training data, and I'm going to work on subset that is training data. Family is going to be binomial because I have categorical data sets. So I just define my model here. And now if I write summary of the model, I get these results, right? Now this is my model which says that I got some values of my, the equation. So I got the values of equations and every value is found to be significant. So I can predict the default rates with income, age, and loan on the basis of the significant scores of these particular values. I'll now make you understand how to read it. Okay. So if I write here, now let me just identify which customer is going to which customer is going to default. So I get the probability of default rates. So I just write here probability default and I say predict. I use a predict function and predict the particular model's probabilities who is going to default using the testing data set now. Okay. And type is basically I'm going to use response. So when I say I'm going to use probability default, I get the default probabilities for every guy. Okay, these are the probabilities values for every individual's prediction. So it's the value is of the particular first person is going to be 8.54. Okay, minus 0.6 means what? 0.00008. So it's having least probabilities for getting the particular default. Okay, apart from that, if I can even get into the predictions, so 0 and 1 based values, I can just write here that all the values which are less than greater than 0.5, make them, they will default. And whatever the values which are less than this threshold, that is less than 0.05, convert them into 0. So this probability default score, which was coming to be 0.0008, something like that, I divide into two part categories, 0 and 1, right? Binarization I have done. So I can now clearly say the client ID number 1904 will not will now default. 1 means what? He will default, right? Okay, what I do is I can work on a confusion matrix and I can get the accuracies here. How to get the accuracies? So the model accuracy, you can see that I can use by mean of this default rates between testing and training data sets, and I just get the particular accuracies as 94%. So 94% accuracy is in my model using logistic regression model to predict that the customer will default or will not default. So what we can go do, guys, now we can see that I can not only apply this particular model over here, I can how exactly these logics are being built up, right? Let me show you. For example, you want to predict something, right? So you have sales value here, sorry, ads value and sales value. You want to predict sales from ads. So values of ads are 1, 2, 3, 4, 5 like that, and the values of sales are 2, 4, 6, 8, and 10. You want to predict the sales value when the ads value is going to be 6, say, okay. So directly you can say that value should be 12, but I need to predict that, right? So how to use a prediction model here? That's what the R programming has done. So what I've done is I basically, this is my new data, that is 6 is going to be testing data. This is my training data. So what I do is I just apply a particular, a model here. What is that model? I apply linear regression model. So linear regression means what? I take up the particular average values of this particular model. So I just have the average value for of this particular cell, that is ads. I take the average of sales. I make a column here, x minus x bar. And what I do is I just simply, deviate all these values from the average. Once I get x minus x bar, I get the values for every column. Similarly, I take the square of it, x minus x bar, the whole square is being taken up to avoid minus sign. So what I do is I just take the square of it, sorry, is equal to this value multiplied with this value again. I get a 4, 1, 0, and 4, right? Next column is basically y minus y bar. So it's going to be now the value that is going to be the sales value minus the average value of sales, that is 6. So I just do that. What is happening? Okay. So I just do that and I just scroll it down. So this is the y value minus the average is 6. I scroll it down, I get these values. I take the square of it, y minus y bar, to avoid minus sign, to the power 2. I take 4, multiply with 4 again, I get 16. I get these values. Ultimately, I have another form, the kind of a column which says x minus x bar multiplied with y minus y bar. Okay, which means what? I'm going to take the product of this column, that is 2 minus 2 multiplied with this column, that is 4. So I get the particular column again. Reason is that, why I'm doing this, because I need to work on an equation to predict y. Y is my sales. Okay, let me just write here y. This is my x, that is ads. So y can be predicted from ads by using an equation a plus b times of x. Okay, so y is a plus b times of x means what? A is a constant. So what is the interpretation of a? So when your x is 0, the value of y will be what? Y will be equivalent to a only. So when your x value is 0 for any given use case, your value of y would be equivalent to a. So this is that value when you put x as 0. Okay, the value which is left is a, that is the intercept. Okay, all right. So what I do is now I just want to prove this equation is there. So this b part is to be identified. This b is nothing else but covariance between two variables, that is x and y, input and output, divided by variance of your input, that is x. So the formula of b I'll write again. So b is equal to what? Covariance between x and y divided by variance of your x. This is basically nothing else but the numerator part and the denominator part. Numerator is what? So if I want to identify covariance of x and y, okay, x and y covariance I want to identify. So I can use this formula, right? Summation of x minus x bar multiplied with y minus y bar, okay? And the downside we have variance of x, right? So the variance of x is nothing else but summation of x minus x bar and take the square of that. That's it. So instead of y minus y bar, I just remove that and I take the to the power 2 to make it clear now. All these values I have already identified in my given columns. So I have got the value of y if I get value of b. Okay, I can get the value of a because a can be identified by using equation y bar, that is the average of y minus b times of x bar. A is a constant, so it can still be a constant in any given use case. So I have y bar is average, so the formula of a is nothing else but 6 minus b times of x bar. X bar is already 3. All right, so I just need to identify b now. B can be identified using this equation, which is covariance divided by variance. Covariance can be identified by this column, so I just take the summation of it. I get the covariance. So this is my covariance, that is 20. So this for portion is 20. And then I divide by variance of x. Variance of x is x minus x bar the whole square, right? So I just take the sum of that, which is going to be this. So I get 10. So I get 20 divided by 10 means what, guys? I get the value of b as 2. So b is what? 20. Okay. B is equivalent to 20 divided by 10, which is equal to 2. So I got the value of b here. I just put this particular value of b here, and what I get the value of a. So 6 minus 2 times of 3 means what? I got the value of a as 0. So my equation is y is equal to 0 plus 2 times of a given value of x. If my y is this, sorry, x is 6, I get 0 plus 2 times of 6, okay, and hence proved my y is 12. Okay, what is the error here? So error can be identified y actual minus y predicted. I predicted that the value of y will be 12. So I say 12 minus 12. So I get 0 error here. So machine learning is nothing else but at what level of your alpha and beta, that means at what level of your a and the value of b, your model gives error almost 0. That's machine learning, right? This is machine learning to just predict from the past data, get the minimum errors, maximum accuracy. Now clear? So what I do is basically I work on this kind of algorithm, which is which in turn is going to be very problematic if I do it manually. So what we do is we use Python programming, R programming, this kind of things, and then we make it. All right, guys. So I think you enjoy the session, right, Jamie and everyone. And now we can say bye bye because the entire things which we have discussed so far are being covered up. So we can use either a particular programming for this. The same equation you get it here on the R programming also. So once I said that I am working on a summary of a model. So this summary of a model can be worked out because here I get the value of B for income, that is beta B1, that is dependency of my default rate is minus 2.577. So if income is high, minus sign indicates default is less, means there is no chance of default. If age is high, default is going to be less. That means there is no chance of default with high ages. Loan, if it's high, obviously it is plus. That means 2 times of loan would be the default rate. So default is dependent twice on my loan, almost twice of loan. That means what? If there is a loan, definitely chances of default increases. If the age is high, chances decreases. If the income is high, chances decreases of having a default. Okay guys, thank you so much. Until then, happy learnings.